Hi, I'm Berke Herren from Germany. I invented an algorithm, a very special algorithm. And it's a nonlinear fractal algorithm that explains the distribution of all prime numbers and gaps. It has 3 fractal processes: move, copy, and change. Let's see it at work. This is the game piece. I put it on the 1. At this point, I don't know anything about whether prime or composite number, and this I denote with the symbol L, which means live, undetermined. And I put a period sign above it, meaning it repeats itself. Every number in the natural numbers to infinity is L, undetermined whether prime or composite. And whenever I find an L, that's the rule, it's a prime. But oh, we have number 1, and there's an exception right in the beginning. Number 1 is not a prime number. So instead of putting a prime up there, I put the symbol 1 up there. And now, fractal process move. I move the L from the beginning to the end of the pattern. Fractal process copy. It's supposed to be there 1 time. That's already it. And change, well, that's an exception too. 1 doesn't make multiples, doesn't make composite numbers. Therefore, the L stays. Now I put my game piece on 2. And I look which symbol I find. I find an L. And L means prime. So 2 is a prime number. Now, fractal process move. I move the L to the end of itself. Fractal process copy. So I put another L because it's supposed to be 2, the pattern. And now process change. I count 1, 2. This is a composite number, a multiple of 2. So I change it to an M. And that's it. From here on, the pattern LM repeats itself. That's why the period sign's up there. LM, 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 and so on to infinity. Now I put my game piece on 3. I look at what symbol? It's L. So 3 is a period, is a prime, sorry, is a prime. Now fractal process move. I move the L to the end of the pattern. Then I copy. It's supposed to be 3 times the original size. So 3 times 2 is 6. And you see, that size 6 is the primordial, meaning 2 times 3 is 6. So now I repeat M, L, M, L, and the whole thing is one big period. Now, after move and copy, we've got the fractal process change. We count 1, 2, 3, 1, 2, 3. Oh, there's an L here. It has to change to M. Now we're done at this stage. We've got ML, ML, MM. And from this standpoint of the 3, if you look all the natural numbers to infinity, this pattern repeats itself. ML, ML, MM. Now, I put my game piece on 4. Oh, I look at the symbol, it's an M. So 4 is not a prime number, but a composite. It's a multiple. Then I have to do fractal process move. And I move the first position to the last position. Whenever we have a composite, a multiple, we only have fractal process move. Because multiples don't copy and they don't change anything. And from the standpoint on 4, the pattern for all natural numbers greater than 4 is L, M, L, M, M, M. L, M, L, M, M, M. And so on and so forth. Now I show you a video from my research where you can watch how this pattern explodes through copy. It moves, copy, and changes whenever there's an L, and it moves only whenever there's an M. And without putting my game piece on 5, I already can see in the pattern that 5 and 7 are primes. So I have a list of defined numbers 1, 2, 3, 4, and I can see the next prime, and that's really revolutionary.